What is up, guys? In this video, we're taking a look at data types in Rust. There are four major types: integers, floats, characters, and booleans. So now we're taking a look at integers. So with integers, you get these ones: 8-bit, 16, 32, 64, 128-bit, and then you get something called as architecture. We'll talk about that in a minute. So for 8-bit to 128-bit, or actually all of these, you'll see there's a distinction between I and U. Okay, so you'll have I8, U8, you'll have I16, U16, but there is a distinction between I and U, which is basically unsigned unsigned variables and signed variables. So what does that mean? So when you are expecting the integer to either be positive or negative, or carry around its positive or negative sign with it, then you would want to use I. But if you don't want any number to be characterized as positive or negative, and you just don't care about that, and you're expecting something to be always positive, let's say, you would be having unsigned variables. Okay. And right now, it might not make sense to you if you're coming from a language like JavaScript. It might not make sense to you as to why there's a distinction between unsigned and signed. But with Rust, you want to have like very strict control in the sense whenever, let's say, I'm transferring money to somebody, so that always needs to be a positive number. Okay, it can't be a negative number. So that's just an example. Many more such examples where you wouldn't want even by mistake negative numbers to come in any sensitive applications. So that's why you have unsigned distinction for unsigned. And this is why Rust and Golang are very stable if you want to do computations, if you want to do operations, mathematical operations, as opposed to JavaScript. Okay, I love JavaScript. I am a JavaScript developer as well. I use a lot of Node.js and React.js, but credit where credit is due. Rust and Golang are simply much better for building more stable backend applications. So these were your These were your integers, types of integers. Now there's something called as architecture that I said we'll talk about. This has something called as I size and U size. Now size is depending on the type of machine that you have. So you might have a 32-bit machine, it'll basically take in 32-bit, and if you have a 64-bit machine, it'll take size as 64-bit. So if you don't know what your if you want the variable to be dependent on the size of the machine and whatever bit machine that you're using, then you'll just use I size. That's as simple as that. Okay, so I hope you've understood between I and U and why they're different and why you even have that in Rust, right? Why you even have that distinction in Rust. Now let's take a look at floats, and then let's take a look at the other Boolean and characters, and then a Boolean and characters, like I said, yeah. And then we'll take a look at some examples to kind of reinforce what you've learned here, what you're going to be learning with data types. Now the floats that you get with Rust are of two types, F32 and 64. So 32-bit and 64-bit, there are no 8 or 128 in size, nothing like that. This is two of these. And this is what floats look like. They have like a point, trailing numbers after the dot decimal. Okay, so that's what floats are. You probably know what floats are already, so I didn't have to tell you, but just putting it out there. So this is what floats are. You have two types of floats. And Boolean, everybody knows there are two types of Boolean, only true and false. So it doesn't matter which programming language you come from, this is all you get. So that's the same with Rust. Now with characters, you get small characters and capital characters. So Z, you can see, is small and capital. And then you also can have these emojis as characters. You can store that in Rust. So that's pretty cool. Now you have some compound data types. So you have tuples and arrays. We are not going to be talking about tuples and arrays right now in this video, because we have a detailed video on tuples and arrays, because those are important topics. I don't want to just brush over them. I want to have a dedicated video for tuple and for array, okay, because they're very important topics. So I'm just telling you right now that they are also considered as data types in Rust. They're considered as compound data types. Why do they call it compound? Because with a tuple, you can have an integer and you can have a float all together in just one tuple. So that's why it's a compound data type. Okay, and that's what you have. So you have tuples and arrays. Now let's get started with some examples to see how they actually work. Now that we are starting with our examples, just want to tell you that I have created a new project with cargo new, and the name of the project is data types in my case. Feel free to create a new project. And then I got something with the main.rs. I got some code for print line and all of that. I removed all of that, and now I'll be writing my own code, and then we'll run this program with cargo run. Okay, so do that, create a new cargo project basically. So here we'll have our func main. Sorry, I keep saying func main because func main is in Golang, but this is fun main, fn main. And then here what we'll say is we'll say let x f64 is equal to 6.0. Okay. And let's print out the value of x. So we'll say the value of x is, and then you remember these two curly braces will help us to put out the value of x. All right, so now let's run this. So let me clear this out. Let me say cargo run, and I'm expecting the value of x. So it says the value of x is 6. Perfect, which is what we want. Now, so we told Rust that the value, that the type of x is float 64. But if we don't tell it, if the type is f64, but if we don't do that, so we just say let x is equal to 6. Will it still be able to find it on its own? Will it still be able to infer the type, as you call it, in type inference, like you have in JavaScript and you have in Golang? Is Rust intelligent enough to do that? So yeah, it says value of x is 6. So Rust is intelligent enough to infer the type of the variable. So Rust is a great language, right? Anyhow, so that was, I just wanted to show you how floats work and how Rust can infer the types. Now let's look at a couple of more examples. Let's see what happens here. So we'll come here again, we'll say cargo run, and we should say see that the value is true, and you can always change it to false. So like I said, there are two types, true and false. You can see the value is false. Okay, and now I want to show you two types of annotations that you can do while trying to define the type of a variable. So we have a variable called a of type f64, and the value of that would be, let's say, 6.0. And then you'll have a variable called b, and here you won't write, you won't annotate the type out here itself. You'll say it's 5, and then you can annotate the type out here at the end. So this is called as annotation at the end, like suffix annotation you can call it, where you give the value of the variable and then you tell Rust what the type of the variable is, which is i32 in our case. Okay, 32-bit integer, signed integer, that too. So now let's try to print out both the values. So we'll say print ln, and the value of a is this and b is this, and here we'll say a comma b. Now let's see what happens. So we'll come here, we'll say cargo run. Okay, now we can see there's some issue. It says print ln. Yeah, obviously, because I didn't put the exclamation mark there, which you sometimes, miss. I won't edit this out from the video. I want you to see that even, like everybody can miss the exclamation mark, but Rust tells you that you have to add this exclamation mark. So that's pretty awesome. Okay, so the value of a is 6, b is 5. This is what we wanted, right? Value of a is 6, b is 5. Just want to show you that when you open up other people's code, you will see b is equal to 5, and then you'll see i32, and then I don't want you to get confused at that point of time. This is why I want to show you this. Now I want to show you a special example which will throw some people off, and if you've been paying attention since the beginning of this series, then you won't find it very confusing. So we all remember what mutable variables are. We can define a mutable variable x, and we can define the value to be 12, and we can go ahead and change the value. We can say x is equal to 6, right? So this works because it's a mutable variable. The value can be changed very easily. And if we go ahead and print it, we'll say print ln, and we'll say the value of x is, and curly braces, and we'll print out the value of x. Now this will work, obviously. So if we go to our terminal and we say cargo run, we don't expect any issues. There's a warning, obviously, that x is never read and you're trying to assign the value before that. That's all right. It's running, and we see that the value of x is 6, and it changed the value. There's a warning, no errors. That's because we didn't use the value before we mutated it quickly. Okay, so this works, right? Because that's what we learned. We learned that mutable is means that changes. But the question here is, can you also change the type of a mutable variable? Okay, so if we have a mutable variable x, we want to change the type of the variable to boolean. Sorry, not we'll say true. Now, will this work? That's the question now. So if you have been following along, you would probably be able to guess it. Try guessing it. Let's see what happens. Okay, we'll go here, we'll run this program. So it says error, mismatched types, right? So even if it's a mutable variable, you cannot change the type. You cannot mutate the type, okay? Now this is something that's going to be a problem area sometimes, in the sense, you know, you might write a very big program and then you know that, okay, mutable variables, you can change things around, but sometimes you forget that you can't change the data type, right? So I just want you to like allocate some space in your memory for this special bit, that you cannot change the data type even for a mutable variable, but you can change it by shadowing. So if I could go here and I would say let x is equal to true, because, you know, you can say let and then it just changes that by shadowing. And now if I run this program, so you do get warnings, but you get that the value of x is true. Isn't that awesome? So you have now I hope you understand the meaning and how like much deeper meaning of how shadowing and how mutability works, and they are going to be like very recurring themes throughout this series. And these are kind of important things, because this is where most of the errors are created, and my job is to you know, tell you in advance where the errors can get created so that you become a better programmer. Now I have a few more examples for you just to reinforce what you've just learned right now. You will sometimes also see the suffix with an underscore. So let me show you what I mean. When I am declaring a variable, so I'll say let x is equal to 5.0. I'll see something like this sometimes, f underscore f64. If I print out the value of, first let's just print success. Okay, let's see what happens there. So we'll go here, we'll say cargo run, cargo run. And we obviously get success, okay? Everything is fine. Now what we will do here is we want to print out the value of x. So how do we do that? So the way to do that is we just print out x, right? So in any other programming language, you would just be able to print out the value of x. What do you think? This will work or will it not work? So let's see, let's try printing out the value of x. So in this case, it doesn't work, okay? And Rust even tells you how to print out the value of x. You'll have to always put these curly braces there. So you'll put the curly braces there. And then you'll print out the value of x and it will show you the value of x. So you get the value of x as 5, okay? Which is obviously what you want. So this is what I want to show you, that you know, you'll see this sometimes. I don't want you to get confused. In many people write it many different ways, and you will see this as well. So just wanted to kind of, you know, acclimatize you to the to how people are going to use you know, these suffix annotations. All right, guys. So one more example where we'll kind of revise all the things that we've learned in this video. So let's take a variable called x. It's i32, value is 5. Let's take another variable which is mutable. It's y and it's u32, value is 5 again. Now I want to assign the value of x to y. Okay, what do you think will happen here? Because I know we've just learned that you can have a mutable variable and we can change the value of y. That means if y is mutable, we can always change the value of y. But we also saw some time back that you can't change the type of y, right? In the sense, if I try to assign true or false to it directly, I won't be able to do it. But here we're doing an indirect association, indirect assignment, where x has a particular value and y has a particular value, and both the values are same, right? So remember that both the values are same, but they're of different type. So technically they're the same type. They're both integers, right? Unsigned and signed. So technically the same type. But we're doing it indirectly. So if we were doing it directly, like, you know, try to assign y something, it won't work. But now if we're doing it indirectly, like y, like x is becoming equal to y, will this be allowed by Rust? think about it. Will this be allowed by Rust? So take a guess, okay? And in the same program, I'll also write something else. I'll say z equal to 10. What I'm saying here is that will Rust understand what data type is 10 and then assign it to z, or should I specify like this specifically, right? So I'm not doing that. So will Rust be able to determine what this is and then assign it to z? And at the end of all of this, we'll write success. So what do you think should happen? Let's go ahead and try it out. So we'll say cargo run, and we get errors here. We get some issues, okay? Firstly, the issue is that I didn't put this in these double quotes, but still the errors remain, right? It expected U32, but it found I32. So you can't have that kind of an assignment in Rust. Even an indirect assignment where you're saying that, both the values are 5, so what's the problem? Both the values are 5. And I'm not even directly assigning y a different data type like boolean or character. It's all like technically it's an integer, and I'm still doing it like an indirect assignment where I'm saying y is equal to x, which is another variable, and not saying the direct value, right? It's an indirect assignment. Even then it's not allowed by Rust, okay? Even then it's not allowed. So here, if we make this I32, then Rust should not have a problem, right? So let's try and check it out. So here, yeah, Rust doesn't have a problem. It gives you the value, it gives you success. It does gives you a little bit of warnings here and there, but that's all right. I mean, we're expecting them because we're not printing out those values, right? So it will give us a warning. So I hope you have learned quite a bit in this video, right? These are foundations. I'm spending a lot of time in foundations because this is what will help you build up your knowledge. And like I said, we have a parallel series that will be going on, which will be 50 Rust projects from scratch. They will not be very simple projects, and this is why I'm running this series, so that I'm able to build up your knowledge, so that you don't ask me a lot of questions there when we actually build projects. You'll be able to actually apply all of your knowledge there. So for me, building projects is a lot more fun, right? Because I just get to do my thing and I can just explain a little bit and then get away with it. But what happened with Golang, with my Golang series, is that a lot of people, they started bombarding me with questions that, hey, what does this do? What does that do? We're not understanding anything. And then I realized that, if I want to teach some projects, I'd have to teach the basics as well, because somehow if people see like an e-commerce in Golang or e-commerce in Rust, they assume that they can start building that project with me without knowing Rust. I don't know why they do that. So at least I can then redirect them to my series and say that, hey, do this and then come here, because exactly these concepts are being used in my projects. Anyhow, so I hope you have subscribed to me by now already. If you haven't, please do. Thanks a lot for watching, and I'll see you in the next video.